Hello guys, welcome to lesson number 3. Now, in the past lessons we talked about the sketching and we talked about basic types of extrusion. Now, I hope you guys worked on the sketch tools and the sketch constraints. Now, we're going to talk about something that is very useful in creating a sketch or sketch features. And that's the construct line. That's the construct tab, that's right there. Now there's various different methods that you can construct planes, axes, and points. Now these are important. Why? Because they allow you to create sketches on planes other than the ones that are defined from the origin. Now the ones that are defined in the origin can be seen under the origin tree, but these are not always what you need when you want to create a sketch at a certain point. Now we're going to talk about those. Now, for reference, I'm going to open up the XY plane and I'm going to make it visible. Let's close the other ones. Okay. Now we can see the XY plane, which is also considered the top plane, or if you look at it from the bottom, considered the bottom plane. But this is in relation to the origin. But let's say I want to create something that is at a different distance from this plane. So that's the first option we have, the offset plane. Now, the offset plane is important because it allows you, in the most basic terms, to create planes at a distance from other planes or surfaces. Now, let's do one with the XY plane. Let's click the XY plane and we can see that an arrow pops up with a distance marker. And if we pull on the arrow, you can see that the distance changes. And if we look at it from the side, we can see that this new plane is completely parallel to the XY plane, but 30 millimeters above. Okay, let's click OK. As you can see, we have a new item on the tree on the left-hand side called construction. Everything that is created from the construct tab over here will be under the construction tree. And if we open it up, you'll see that it is named as plane 1. Now, it's good practice, especially if you're creating a complex model, to name these, okay? You can right-click on it and select rename and give it a name. I'll say above top for now. Click enter. So it has its own name. Because once you start creating complex models, you might want to close this off, okay? So you're not going to be able to see them, but if you remember, or if you give it names that you can remember, you can just open that one up and work on it. Okay, so this plane allows me to sketch on it. What I do is I select create sketch, and I select the new created plane. Okay, now as you can see, my grid is above the XY plane. It's at my newly created plane, and if I sketch on it, I will be able to create an object that is referencing this plane. Okay, now, you can see the XY plane is on the bottom, and my rectangular prism is above that. Okay, now the next one is the same. I still select offset plane, okay, but instead of extent, instead of selecting distance next to extent, I select to object, okay, and in this manner I can select an object that I want to put my plane as a reference point. What does that mean? Well, let's say, let's say, okay, let's create a basic example. I'm going to sketch on the side of this rectangular prism. I'm going to make a cutaway, okay? I'm going to make a cutaway. I'm going to sketch a triangle, okay? Close the triangle, have a closed contour. Then select extrude, select my triangle profile, and cut it off, okay? I can either make sure that this triangle goes all the way through my rectangular prism, or I can just click where I want it to end, and I want to end at this plane, okay? And I say, okay. I need to make sure that the operation says cut. So another way to check it, it's red. Red means it's cutting, okay? Sometimes when you're cutting multiple objects, you'll see that the objects to cut have all the bodies that you're going through. So you might need to select a certain body, but because this example has a single body, I'm going to select OK. Now, I have this cutaway rectangular prism, but I want to make a plane right at this point, okay? However, there's no plane for me to sketch on that point. So what do I do? I select offset plane. Instead of extent distance, I say extent to object. Now, I have two things that I need to select. The first one is my reference. And for this reference, I'm going to start with the XY plane that we see on the bottom. Okay. Now, the second one is the offset. The offset plane's starting point, the object. And that one, I select this point. That is where the triangle top part is. Okay. And as soon as I do that, it's creating a plane that is parallel to my XY plane at this point, okay? You can vaguely see the yellow, orange marker, okay? And when I say okay, I have another construction in my tree. I can see another construction item called plane 2. Let's rename that. Let's say inside triangle. Okay. Now I have this inside triangle, which I can sketch on. And that's sometimes useful if I want to do something from the middle of my object towards the top or the bottom. Let's select the inside triangle. I can select it from my tree. I don't have to select it from my model, and this is a quick tip. Now, if there's something inside of my model and Fusion is giving me a hard time in selecting it, what I can do is I can come over that object, close to that object, somewhere inside of that, and I can keep pressing the left mouse button until a menu pops up. Now, this menu lists everything that is under my mouse cursor, okay? There's a face, there's an inside triangle, and there's the back face, okay? Now, I can select inside triangle from here as well. Now, I'm selecting on that plane. And let's create a circle, okay, that is inside of the prism. And let's extrude that circle. Let's make a cutaway, okay? Now, I know that this bottom of this cylindrical cut is right at the middle of my object. So that's how I do that. Now, another option in creating an offset plane is not using your reference planes or your construction planes, but using any surface, okay? Any surface that is flat. So, let's say I want to create some other object a certain distance from this object, okay? So what I can do is I can select one of the surfaces on this object that is flat. I can click on it. Then I can write down or with my mouse get a distance. I can say, okay, now I have a construction plane a certain distance from this object. Okay, let's hide these for now. Let's hide the bottom plane and the newly created plane. Okay, now the second one, plane at angle. Okay, as the name suggests, this construct feature allows you to create planes at an angle, but it needs a line to make you create that angle. So the plane or the point is not what we're looking for. We're looking for a straight line. What type of line? Well, it can be two types of lines, basically. It can be a construction sketch line, which is without a model, or it could be from your model. It could be an edge. So let's do both examples. This is an edge on my model where my mouse is. I'm going to click that edge, and I get a plane. But I'm not done yet. I need to tell it the angle. And this is my angle adjustment. Okay? That's how I adjust the angle. And if you look at the box, the numbers are changing. I can also manually input my angle in this box. So let's say I want to do something at 45 degrees. I select OK. Now I have a 45-degree angle construction plane on that edge. And I can sketch on it and make a feature. Okay, let's hide that one. The same thing applies for an axis. Let's open up my axes. I'll open these up from the origin. As you can see, my three axes. And let's select plane at angle. Okay. And as soon as I go over one of my axes, I can create. Let's do one on the X. Okay. Gives me a flat plane and my angle adjustment. Okay. So that's how I create an angle from an axis. The same can be done with a sketch feature like a line as well. Okay. Now, the third one, the tangent plane. Now, the tangent plane is important because you will use that mostly if you want to make a mark on cylinders, make a sketch on cylinders for some reason, and we'll do one right now. Now, the tangent plane is asking for a face. It's not asking for any face. As you can see, the faces that are not cylindrical are not lighting up. They're not highlighting. But when I come over the inside cylinder, I'm getting a highlight. Okay? So let's select that cylinder. And as soon as I select my cylinder, it's giving me a plane that is parallel to the reference plane that I clicked closest to. Okay? So once I have that, I can rotate it, and it's always tangent to the walls of that cylinder. Okay? I can also select a reference plane that I want to start as my 0-degree angle. Let's select a reference plane And like I said, it doesn't have to be a plane in terms of a construction plane. It could be any surface that is flat, that is also perpendicular or parallel to the cylinder walls. So let's select this front small rectangle, okay? And as soon as I click that, it became parallel to that front plane. That's now my 0 degree angle, okay? Okay, so that's how that works. Let's click OK. Let's make sure it's not visible. Okay. Now, midplane. Midplane is also very useful when you're creating symmetrical objects, for example. It's probably the most used construct type, I would say. And there are a few things you can do with planes, which I'm going to do an example with the midplane. Okay, so what does the midplane do? Well, the midplane creates, like the name suggests, a plane right in the middle of two parallel surfaces or planes. What does that mean? Well, let's say I want to cut this object right in the middle. I select the leftmost surface, then I select the rightmost surface, and I get a plane right in the middle of the object. Okay? Then I select OK. Now I have a plane going through my object. And a new feature that you guys will learn now is called split body. It's right on the top. What I'm going to do is I'm going to use this newly constructed midplane as a cutting object. Okay, so I click split body. Fusion is asking me on the right hand side the body to split. Okay, I want to split this body. Okay, it's asking me the splitting tools. So I select that. I select the newly created midplane, and Fusion is showing me an approximation of the cutting item that will go through my object. Now, sometimes the plane that you have might not be going all the way through the object. At those times, before selecting splitting tools, okay, you can say, let's restart the process. You can say split body, and you can say extend splitting tools. Okay, if I unclick that for now, I say body to split, select splitting. No, that's not the right one. Select splitting tools. Because my plane is going all the way through my body, it will still cut it. But if I had something that was smaller, which we'll get into, let's do an example. Actually, we do have one here. Okay, let's cancel. We'll do the midplane cut in a second. Let's say I wanted to use this inside surface of the triangle cutaway as my cutting tool. Let's say split body. The body to split is this body. The splitting tools, and I'm going to uncheck my extend splitting tool. The splitting tool is this inside surface. I'm going to select that. Okay. Now you can see Fusion is not extending this rectangle to cut all the way through my body. Okay. But if I press or check the extend splitting tool, it will extend it as far as it needs to cut through the whole body. Okay. Now, back to our midplane. Let's do a split with our midplane. Okay. Select our midplane, select OK. Now, you can see there's a black line running through my body. Okay. If I hide my midplane, and if I look under the body in my tree, now there are two bodies. Okay. Well, why would you use this? Sometimes you model the whole thing, then you create a symmetry using a midplane. Then you can play with these bodies, okay? I can move this body, okay? I can move it. Now I have two symmetrical objects, except for the cylinder hole, of course, that are certain distance from each other. Well, now that I mentioned it, this cylindrical tool, this feature that I made, this cutaway, maybe I also want that on the other side. Like what I can do is, if I come down to my history below, right there, you can see that my move is also recorded in my history. Well, if I right click that, and if I say delete, the object is going to move back, okay? I want to make this cylindrical hole on the other side as well, but I don't want to go through the feature. I don't want to go through the whole sketching and extrusion phase. And I'm sure I want to make it symmetrical. So what I can do also, I can unhide my midplane. Then I can go into what's called the mirror. I can click it, and I can say, I want to mirror this feature that I want, but I have to select the object type. So what I do is I go down to the menu of object type, and I say feature, because the extrusion process was a feature. I select that. It's asking me what feature I want. Now I can select my cylinder, or I can go down to my history, and I can mark my feature from my history. Sometimes it's much clearer to mark the feature from your history. So sometimes it's easy to select because this is a very simple object, but sometimes the object gets complex in terms of its model features, and it's easier to select it from the history. Okay, we have our cylinder extrusion selected. It's asking me the mirror plane. Okay, so the mid plane that I created will be excellent for this. So I select that. And it's asking me the compute type. Now this is important because you will face this problem in Fusion. There are three options: optimize, identical, and adjust. Now the optimized is a calculation. We talked about precision in class and accuracy in class. Now, optimized will give you the highest precision that you require for this object to be considered exactly mirrored. However, it might not be exact in terms of its maybe 6, 7, 8 digit precision, but it will not be a problem. Now, identical will try to create it as an exact placement. And the adjust will adjust it according to the complexity of the model. Now, this is a very simple mirror type, but you will do much more complex mirror types, and you will need to go through these options. Some might fail, some might work, depending on the mirror type. And in this example, we'll do an identical. Okay, we'll click OK. Now we have two cylindrical holes that are mirrored, and they're at a certain distance, the exact distance, from the midplane. Now, how do we check these distances? Well, in Fusion, here's another tool that you guys will use a lot. We have this thing called the measure tool. Now, if we click the measure tool, you will see your selection filter on what you can select. You can use this filter if you're working on a complex model, but I usually leave it at faces, edges, and vertices. The precision, okay, if you want to override what's in your preferences, you can do it from here. I leave it as the default. Secondary units, if you need something in, I mean, right now we're working in millimeters, but let's say you want to also be able to see it in centimeters or inches or feet, for example. You can select it from here. I leave it at none. And after that, all you need to do is select your first item and then select your second item. Now, if you look at here, Fusion is giving me a distance. The distance, the maximum distance, and the minimum distance. Now, if we look at it from the top, it might be a little bit more easier to see. Now, because we're measuring the distance between a surface that is flat and a surface that is cylindrical, we have three different measurements. The first one is the closest point of the cylinder wall to my flat plane, flat surface. The second one is from the center of the cylinder to my plane. And the third one, the middle one, the maximum distance one, is from the farthest point of the cylinder to my plane. Okay? So, depending on what you need to look at these. Okay? Now, this measurement tool is not only used for distances. As you can see at the bottom, Fusion gives you all the other values that it thinks you might need. Okay, we have our radius, for example, the diameter, the area, and the loop length of this cylinder. Okay, which is great. Now I unclicked it. Oh, let's check the number again. Let's memorize the number. It says 7.3798. Okay, let's do the same with the other cylinder. 7.3798. Okay. Now, we have the same distance. Now we can move it. Okay, let's see what happens when we move it. Okay. Now, here's an interesting thing. Let's say I didn't like the placement of this cylinder cutaway, and I go back to my sketch, the one that I created, the original cylinder, and I move it. Okay, I move it. I actually move it outside the walls of the object. And I say finish sketch. As soon as I say finish sketch, you will see that the other object has the same modification applied to it. Okay? This is an important thing to keep in mind because this might not be what you're expecting. You might be thinking, because I detached this part from the original part, they're not connected anymore, but that is not true. Why? Because Fusion follows the history line, this linear history line, when it's recreating your object after you modified the history bar. Now, watch again. Once I edit this sketch, everything that is after the creation of this sketch is grayed out. It's just like they don't exist. So, once I say finish sketch after I move my circle, Fusion is going to go through them one by one and recreate your history according to the modification you made. So, that's why this mirrored object will be affected by what's going on your main object. But here's a big but. Let's make a modification to the second part. Let's create a hole on top of this. Let's go through it. Let's say, okay, it doesn't work the other way around. After they've been modified, split, moved, it doesn't mean they're connected after this movement. So let's make a hole in this one. Let's make a square. Okay, let's make it go through this. Okay, I can modify them after the fact, but whatever I do before this mirror object will be replicated on its symmetrical part. Whatever I do after it will not affect the other mirrored part. Okay? You need to keep that in mind because that's something that can confuse some people. Okay, now here's another good thing. Let's say I want to go back to that point. I want to go back to explaining the construct, and I want my simple object back. I can select this history marker and take it back in my history. I'm holding down my left mouse button, and I'm going back to the place where I created the midplane. Okay. If I right-click my marker now, I can say escape. I can say delete all features after history marker. Okay, and once I click that, everything that I created, everything that was grayed out on the right side of my history marker will be deleted. Okay. Now, sometimes, because of the mirrored thing that I showed you, let me select let me undo what I did. I do Control Z. Okay. Control Z, undo. On Mac, it's Command Z. Let's say some things I did after the mirroring, but I wanted to have that feature on the other side as well. So what I can do before doing any modifications to the model, what I can do is, let's say I don't like this cylinder, so I'm going to get rid of the cylinder. Okay, I'm going to delete the feature. I'm going to also delete the sketch. Okay, and I'm going to pick this sketch and this feature, and I'm going to hold down my left mouse button, and I'm going to move them in my history timeline. Okay, the furthest that I can move them is after the split, before the mirror, after the split. So I'm going to let go of my left mouse button, and I'm going to move them before the mirror. Okay, now that's interesting. Okay, now I'm going to move my history marker back, and I'm going to move it back once again. So after I move my history marker, you will see that I only have this cutaway from the cylinder. But here's the nice thing. Let me pull this back. Okay, here's the nice thing. If I right click on my mirror, I say edit feature. Okay, I can go into the feature set that I had created where I had selected the cylinder. I can hold command in Mac or control in Windows and also select the square cutaway that I did. As you can see, the object number has increased to 2. Then I say, okay. Okay. Now, here's a nice thing. It failed. It failed. Compute failed. Try adjusting the pattern settings or changing selections. Now, this is a great example. This is happening because of the identical. It is having a hard time calculating the exact placement of these objects. So, let's select optimized. Okay, let's click OK. Whoop, it failed again. Okay, let's say edit feature. Let's select adjust. Adjust. It clicked, it failed again. Okay. Now this is something that you will see in some modeling programs, especially in Fusion. You will see this. There is another way around, of course. Now I'm going to place Control Z, Control Z, Control Z, and go back to my original mirror. And I'm going to move my object back. I'm going to create another mirror. Okay. I'm going to select my feature, select my mirror plane, and go through identical, optimized, and adjust again. First, optimized. Okay. It's failed. Okay. It says compute failed. No pattern instances could be intersected with the original value. Okay. Let's select another one. Let's say mirror. Feature. Okay. Mirror plane. Hit plane. Let's say identical. Okay. It fails again. Let's say mirror. Feature. Let's select my square cutaway. Select mirror plane. Now let's select adjust. Okay. It failed again. Now, this happens sometimes. Fusion is having a hard time calculating where this square cutaway is. And it does happen. And if this happens to you, it's a good practice to re-evaluate this cutaway that you did. Okay? So let's look at the cutaway that we did. Okay? Let's see if we can see what's going on. Okay, there doesn't seem to be anything wrong. Okay. Let's see what would happen if I move this cutaway, if I did the same feature before the body split. So let's see. I delete the body split. Delete. Okay. I have this feature, sketch. I have the sketch. I need to see the sketch to extrude it. So I make it visible. I select the profile. I make a cut. Then I move it back to before the cut, and I reselect that feature. Okay. So the only difference is I didn't split the body yet. Okay. Now it works. So this split body command does create problems in some models. It will not always create this problem. However, it's a good practice to create all your features before you split the body, and especially before you split the body and then move the body. Okay, so now we can resplit the body with our midplane, and we can move it. Oops, move it, and now it doesn't seem to have a problem. Okay, now let's go back to where we were. Let's go back to our midplane. Everything that is after the history marker. Okay, let's hide our midplane. Okay, what else do we have? We have plane through two edges. Okay, let's select that. Sometimes you will need to create a plane that is between two sketch lines, two axes, two edges, and this might be difficult, especially if your model is not simple. Now, this is the reason you might use this construction method. There are alternatives. I don't use it that much, but let's do an example. I have two edges that I selected. Now I have a plane. Why would I use this, for example, in this model? So if my model was a little bit more different, let's make it a little bit different where this example makes sense, okay? Now let's do a cutaway from this body. Let's do something like an arc cutaway, okay? Let's do something like that, okay? Let's make sure these two are connected. And let's cut this away. Okay, great. Okay. Now we have this weird shape with two concave faces. Let's make a small tip at this point. A lot of people confuse or mistake convex for concave or vice versa. It's very simple to remember this. Now, how do I advise you guys to remember it? Is first of all, you need to know your reference. What does that mean? I'm looking at this object from the outside, okay? And from my point of view, this surface, the middle of this surface is going towards the inside, okay? In English, we might say the surface is caving in. Caving in. It's like a cave, okay? And that's where the name comes from, concave, okay? Caving in. So, this is a concave surface. If the object surface was towards the outside, okay, then that would be a convex surface. So, this is a concave surface. Okay. Now, we have this concave surface on the top and the bottom. There is no way to create an offset plane without using a reference of some other plane that is on this surface. But I want to make sure that I'm creating this surface according to this concavity. So what I can do is I can go to construct. I can say plane through two edges. Select the two edges of this concave surface, okay? And I get this. This is important. Work plane from two lines failed. Input lines must intersect or be parallel. This is very important. Now, we didn't have a problem creating a plane when this surface was flat. Okay. Actually, let's try the bottom two. Let's see what happens. Okay, the same problem. Okay. Let's see what happens if I select another edge. Okay. Let's uncheck that. Let's click one side of the concave surface and the other side. I'm still getting that plane. So here's the precision problem of fusion. We can be pretty sure that we create this convex surface using a sketch that looked pretty straight when we were cutting it. But according to fusion, these two lines on the edges of the concavity might not be exactly straight. Okay. Now this is This is an issue that you will face on some of your models, not all of your models, but in some of them you will face this problem. Okay. If you ask me, and let's see what the measurement gives. Okay. Now the measurement is giving a distance. It's not giving an angle. So Fusion actually thinks that these two lines have a distance and not an angle, which means they're parallel. But at some precision that is further away from this dot, maybe the 8 or the 10 point. Let's see if we can see this. Yeah, see? At some precision, which starts at the 6th point after the dot, Fusion is seeing an angle. There's an angle of this much between these two lines, which I know doesn't make sense, but it happens. And there's no way to correct it, unfortunately. So, just so you know, if you increase the precision, you will see it. So because of this angle, I'm not able to create these plane through two edges. However, if I select these two edges, Fusion is not seeing an angle, and it is allowing me to create that construction plane. So don't get surprised when Fusion says you can't do this because of this, and it gives an error. There are other ways of doing it. So what would I do? What I would do is very simple. I would go into offset plane. I would select two objects in my extent. I would select this plane as my reference, and as my object, I would select this dot. Okay. This plane is accurate enough for what I want to do. Okay. It's the same plane that I would have gotten if I had made the two lines plane. Okay, let's undo this. We don't need it. Now, what's next? Plane through 3 points. Now, this is actually something that is very useful, and you will use this, especially in complex surface models. Now, as the name suggests, what you need to do is you need to select 3 points. You don't select these 3 points that are on the same plane most of the time. So for example, I'll select this point that is at the edge of my cylindrical cut, right there. I'll select this point that is edge of the triangle cut, then I'll select this point. Okay, as you can see now, I have a very weird plane going through my object, which might be useful. Okay, let's see what happens when I cut with this plane. I'm going to get an interesting body. Let's move this. So, that's interesting. Let's hide this plane. So if I wanted to create a surface as such as this is how I might do it. It's almost sculpture-like. Okay? So that's what I have. Let's undo these. 3-point surfaces are very construction planes. 3-point construction planes are very useful. You will use that. Plane tangent to face at point. Now, this is a little bit different than tangent plane because it also asks for a point, a specific point where it will be tangent. Now let's select the cylinder and let's select this point. Now I know for a fact, without getting into any angles, that this plane is completely perpendicular to the vector that would have been created at this point. Okay, so that's a great tangent plane for my cylinder. Okay, You will also use this a lot, especially when working with cylinders, and if you want to cut them or extrude them for some reason, this is a great point. Okay, let's hide that plane as well. Okay, and plane along path. This is also something that you guys will use a lot. Now, especially when we get into some other features like sweeps, you will see the need for this. Now, in this example, it will be very simple. But if I wanted to create a plane that is completely perpendicular to this line, that's what I would use. Okay. Now, I can move this plane at the distance that I desire, and this distance type is called proportional. What that means is the complete line is considered as a single digit length, which is not connected to any type of dimension. Okay, so what that means is your starting point is always 0, and your ending point, however long this path is always 1. So the middle part is 0.5. Okay. Now this proportionality can be used in creating complex sweeps or lofts, but for now we can also change it to physical. Okay, which means your starting point is 0 and your ending point is however long that line is. Okay. Now let's have it proportional. Let's have it at 1. Let's click OK. So I have this plane along perpendicular to this line. Now this doesn't make a lot of sense maybe for this example, but if we had it on this convex surface line, it would make a lot more sense. So what I will do is I will edit this feature, and instead of selecting that path, I will select this path. Okay. Now I have a curve that I can move this in. Okay. You can see I have a curve. This will make much more sense when we get into sweeps. But for now, this is how you create a plane on a curve. Okay, let's click OK. Let's hide this plane. Okay, small break. Okay, so the next ones. Now we talked about all the ways you can create reference planes. Now we'll talk about all the ways you can create axes. But before we get into axes, we're going to touch on another common feature that you will use to create objects, and that is the revolve command. Now, in some programs, you will see this as revolve. Some programs you will see as rotate. Fusion likes to call it revolve. It's very simple, and we'll do an example of that. Now, let's start a new sketch, a new design with a new sketch. Okay, I'm going to sketch on one of the planes. Let's sketch on the front plane. I want to look at that. Let's click look at. Okay. Now, I'm going to start with something that will be my center line. Okay. Now, I created the center line. Okay. And I want to create a shape that I want to revolve. I'm going to create some straight features. Okay, something like that. Something like that. Select OK. Then I'm going to create a tangent curve. So I have a tangent arc here. Let's select that. And from my endpoint, I'm going to start drawing an arc. As you can see, this arc is completely tangent to my last line segment. Okay, it's always a part of a circle. I'm going to click that, and I'm going to continue creating my tangent arc. Now, at this point, I want to end as tangent to the top. So I want my top to be tangent. What I will do is I will create a line as such. And I will make this line a construction line by clicking X on my keyboard or selecting construction from the menu. Okay. Now, what I will do is I will create a tangent arc beginning from that point to this ending arc. Now, as you can see, this point is tangent. I got my small icon there. I got my icons on all my tangencies, except the last point that I created. But I want to make sure that's tangent as well. So what I will do is I will select these two last points, and I will make sure they're tangent as well. So Fusion made a small adjustment to my lines to make sure these are tangent. Okay. Now, I have my closed profile. As you can see, it's highlighted in this light blue. Now I will select the Solid tab and click Revolve. Now, Fusion automatically recognized that there's a profile that is closed. So it selected that automatically, but if you had multiple closed profiles, you could go and select your profile. Now Fusion is asking me the axes that I want to rotate this object around. Okay, so I select axes, then I go and select my first line, and as soon as I click it, it has revolved my profile around this axis. As you can see, the box says 360. Okay, 360. Because of the amount of my trailing zeros, the first three is hidden, but you can just, put your mouse cursor on it and drag to the left. You can see the 360. You can also see it on the right-hand side menu. It says 360. And that's important because sometimes I don't want this revolve to be complete. I want a half revolve. So what I can do is I can go and type 180 there. So that's a half revolve. Okay. I can even make it smaller. I can make a quarter revolve like that. Or I can completely have it manual and drag this icon. Okay. Let's have it be something like 270. So that's 3/4. Okay. I can click the direction that I want. I can say go towards both directions. So I say two sides. Okay. That means I can control the other side as well. Okay. So I have full control over where it ends and where it begins. Okay. New body is selected because this is completely new body. Now, as soon as I move these cursors, you can see that the extent type is now partial because this is considered a partial revolve. Okay. If it was a full revolve, it wouldn't ask me any angles. It would just do a full rotation. But when it's in partial, this is what it will do, and you'll have full control. The other one is to object. I don't have any other objects, so it doesn't make sense. Okay. Now you can see this axis that it's revolving around is called an axis. Okay. Now, if this axis was short, I could have it project that axis to cover the whole profile for my revolve. My axis is not short, so there's no problem. I can unclick that, nothing will change. So I have my revolve now. It's a 3/4 revolve, 270-degree angle. Now, if I wanted to create some other axes on this, to create new revolves, or some type of different plane that I want to create, I could do that. Now, the first one is axis through cylinder, cone, torus. Now, these are all type of objects that Fusion will have an easy time to find the center of. Okay, and let's do an example. So now you know revolve and you know what an axis is used for. An axis can be used for many other things, but this is the major one. Okay, now I'm going to create a sketch on the bottom plane. I'm going to select a circle, any circle. I'm going to extrude it. Okay, but while I'm extruding it, I'm going to control the extrusion angle. I'm going to make it a cone. Okay, so I have a cone that I could have also made using the revolve command, but for some reason I had to make it this way, let's say. Now I want to find the center axis of this cone. Okay, what I could do is I could go and select axis through cylinder, cone, torus. I could select the face of my cone, and Fusion puts a cyan color dashed line right in the middle of my cone. Okay, now I have my axis. What can I do with this? Well, I can cut away from this cone. What I also need is a plane. Well, we figured this out, right? We can go and select plane at an angle. So I will select this newly created axis, and I have a plane. Let's say I want to start like that. I want to start at 9 degrees and select OK. And if I go into my tree and extend my construction, you'll see that it says axes. And I can also rename this. I can say axes through cone. Okay. Now let's sketch on this newly created plane. Okay. Now I know that my plane is created. I can see the grid going through my cone. Sometimes, and this is something that you will use a lot, is I would like to use this cone, the outside lines of this cone, as a reference. Now this feature that you're going to see now is something that you will use a lot. And if you guys remember, I said we'll talk about this later, and now that's the time. It's called project. Now the project command has some options that you can select. Now I'm still in the sketch, so my right tab is open, but the project command has its own tab, so it's the second tab towards the left. It's asking me what type of an object that I want to project from. Do I want to select specific entities, or do I want the whole body? Now for this example, I need the whole body, so I will select that. And I will select my cone. Okay. When I click OK, you will see this purple line going around the cone. This is the place where that newly created plane, the plane 1, okay, is touching the cone. Okay, that's what this purple line is. The nice thing about this purple line is you can use it as a sketch entity. So if I were to hide the bodies, you can see that purple line is a closed profile. So let's do something interesting. Let's cut away from that cone. Let's do this. That's my mid-axis line. I'm going to cut away something like that. Okay, actually I'm going to dimension it. Let's say I want it to be 5 millimeters away from the center. So that's radius. That will give me a 10 millimeter cylinder in the middle. And I want this to be 15 millimeters high. And I want this to be 15 millimeters from the bottom. Okay. Now I have this. Because I have these purple line projection and my rectangle intersecting, I have 3 closed profiles. This is the first one, the cone projection. This is the second one, and this is the third one. What can I do with these? Let's see. Let's go and select solid, then revolve. And let's unhide my cone. Now, the first thing I can do is I can select the inside profile and my original axis, the blue one, and make a cutaway. Okay, so I have this. That's like a sphere, almost. The second thing I can do is, instead of selecting that profile, I can select the outside profile. And I can rotate, no, not that one. Like I have to select my operation first. I have to select join, okay. Then have a controlled step on my cone. Let's say something like that. Okay. I can select join. Okay. Now I have a step on my cone. These two are connected. Or what I can do is I can say new body. Okay. And select OK. Now I have 3 bodies. This is a separate body that I have made according to this cone, which I can also move. Right? So I made something like that. So this is what the project command enables me to do. I don't have to measure anything. I can get a dimension or a sketch entity right from the cone itself. Okay. Okay. Now let's hide that. So that's my axis through cylinder, cone, and torus. Okay. Now it says axis perpendicular at point. Okay. Now let's do that on this one. This is, let's hide this axis as well. This is very similar to plane along path, but instead of a plane, we'll have an axis. Let's select this point. Let's select my face. Okay. Okay. Now you can see that an axis was created. Let's click another point. Okay. You see an axis was created right there. Let's select another point. You can see that this is creating an axis at the place that I'm clicking. Okay, let's click the other face. So it doesn't actually have a dimension. It's not something that I dimension, but it's something that I put on a face without the dimension. Now, this can be useful when creating other features that depend on this axis. For example, creating a plane at an angle. Okay. Now, this might not make sense right now, but sometimes it doesn't matter where the axis is as long as it allows me to create this plane at an angle. Okay. Now, this 60-degree plane might have been here, here, or here. As long as it's 60 degree, it would have been fine. Okay, so that's where the axis is useful. Now, there's the same, very similar command. It's called the axis perpendicular to face at point. Okay, now let's try that one. Let's see the difference. Okay, now it's asking me to select the face and a point. So I select the face, it's expecting a point. So I select the point. Now it's created an exact placement for that axis at that point. So if you need it to be at a certain place, you use axis perpendicular to face at point instead of axis perpendicular at point. Okay? So there's a slight difference between the two, and it depends on what you're doing on selecting which one. Okay, let's select cancel. Let's delete this one. Okay, what's next? We have axis through two planes. Now, so I have this plane and this plane. Now it has created an axis. Now, we can't really see that axis, but if we were to look at this and look at this, you can see we have this new axis in the middle of our revolve. So even though we started this revolve by creating our original axis, this one can also be created with the intersection of two planes. So let's do something else on this one. Let's create an axis with the bottom and the side. Okay. Axis through two planes. I'll select the bottom, and I'll select this one, and it's creating an axis where these two planes intersect. Okay. Now this is useful especially when you're creating objects that are getting complex and you need reference axes. This is a very easy way to create them. Okay. Now we have axis through 2 points. This is very handy. You can also do this with a sketch, by the way, but this one makes it a little bit easier. Let's say if I wanted an axis between this point and this point, now I have. Then I could just create a plane at an angle, like that. Okay, 90 degrees. Then I could do a sketch feature that goes right in the middle. For example, something like, let's say, a cutaway that goes right in the middle of this. Okay, now that's symmetrical. Something like that. Okay, so let's hide these. And then we have axis through edge. Now, axis through edge is something that I don't use that much because I can do the same thing with a sketch, or I can use that line. But sometimes you might want to combine these axes through edges. What does that mean? So I have my axis through edge selected. I'll select my first edge. That's my first axis. Okay. Then I'll do another one, axis through edge. I'll do that one. Now I might need to know where these two meet. Okay. And you can make these axes bigger by clicking the ends, okay, the ends, and dragging them. Sometimes they might be hard to select. At those times, you can left click and wait for it to be selected. Left click, it opens up. Okay. Still, it's very hard. Get closer. Okay. So you can extend them, right? You can extend them. Okay, that one's extended. Let's extend this one. Okay. Now, I might need to use where these guys meet. Okay. For example, I can say point through two edges now. And that's the third thing. We're going into the third thing now. We're done with axes. I can say point through two edges. I can select my first axis, then my second one, and you can see Fusion put a point right there. Now, what's this useful for? Well, we'll go into another feature now. Let's say I'm creating a hole. A hole is the fourth option that you have on the default menu in Fusion. And as soon as I click hole, I have this right-hand menu open up, and it's asking me face or sketch points. Okay, so now I created a point right in the middle. Okay, I can use that point to create a sketch plane to use for this whole feature. So what I can do is I can select this, or no, select my offset plane. I can say to object. I can select my bottom plane. Then I can select this newly created point, and I can have a plane right there. Okay. Then I can sketch on this plane to create a hole, for example, towards the bottom. So that's what it's good for. Let's hide these. Now the same type of usage is also point at vertex, and the name is very clear. You can create points at vertices. I never use this one almost, so it might be useful at some point, I don't know. But it allows you to create points at vertices. Now point through three planes, this one's interesting. For this to work, you need three planes, as the name suggests. Let's hide let's hide this. Sketch is hidden. Okay, the origin is hidden. Okay, everything's hidden. Okay, let's go back to point through three planes. Now, let's say this is my first plane, this is my second plane, and this is my third plane. Okay, I say okay. Now, at the meeting point of these planes, Fusion has created a point, and you can see that one right in the middle. And because this revolve was created in the center, don't mix it up. See, if I hide it, you can see that it goes away. This is not the origin point, this is my newly created point. I can also do this with the center point. Same as, actually let's do that. Let's do that one. Let's edit this feature. And instead of selecting this plane, let's select this plane. As you can see, the intersection point of these three surfaces is at that point. If I unhide it, it's actually the same point I created with two edges. So here's another way to do that. Okay, now point at center of circle, sphere, or torus. Let's hide this one. Let's open up this one. Actually, let's open up this one because it's much more useful. Now I have a half of a outside ring, and I want to find the center point. I click this, and because this is a segment of a circle, Fusion knows exactly where the center point is. I can actually select this one and get something that is below. So this is the top one, this is the bottom one. So now I have a center point. If this was the only object that I had, I could create an axis for that, for rotation, right? I could go and say axis through cylinder, right? Select the outside and also create an axis, right? If this was the only object that I had, this would be a good way to find the center axis. Okay, so let's hide those. Then we have point at edge and plane. Now, for this one, we have an edge and a plane. Now the plane, I need to get this plug. I'll be back later. Okay, plug the laptop in. Okay. Now, it's asking me for a line and a plane. Now, I have selected my line. I'm selecting the plane. It's not allowing me to select the plane. Why is it not? Because it's looking for a perpendicular plane. And how do I know that? It's very simple. This plane and this bottom plane, it's not perpendicular, nor is this one. But as soon as I select the front plane, it's giving me an highlight. Okay, so let's select this front plane. As you can see, it created a point right at the intersection of this edge and that plane. So if I look at it from the side, I can see it right there. Okay, right there. So this is something that I use. It's good to find intersection points sometimes that are not on the model. Okay, so that's what I have right here. Let's click OK. Let's hide that. Okay. And my last one is point along path, which is very similar to plane along path. Okay. So I can select a curve and I can select where I can place my point. As soon as I start dragging where I place my point, I get my beginning, my center, and my ending snap points. And the same thing applies. Proportional distance, 0 to 1, or the exact physical distance as in millimeters. Okay? So that's how you can control that. Okay, so that's where I'm putting my point. Okay, so these are all the construction types. I know it's a lot, but you will get very used to them. It will be second nature because you need these construction types to be able to create sketches. Okay, so I would experiment with them and try different things using these construction elements and sketching on them and doing extrusions, revolves. Okay, I would also try to practice the mirror command and see how you handle it, and also start practicing the projection command. For example, as a last example, I'll do the projection command on this plane. I'll create a sketch. Okay, let's look at it. Okay. Actually, before I get to that, I was going to talk about something which I left to this video, but I almost forgot. It's this slice command we didn't talk about. Now, with projection, we're going to talk about slice as well. So let's start with projection first. So I'm sketching on this small plane. I'm going into create project. Okay. So I click project. It's asking me what type of projection I want. For this example, I'm not going to do a whole body. I'm going to select my entities, and I'm going to select these 4 edges. Okay. I'm going to select OK. Now I have these purple lines around these edges, and I can see them more clearly if I hide the body, right? Like that. Now, one of the things that we skipped was looking at projected geometry. So if I hide this, you will see the purple lines disappear. Okay, so now you know that. And the other thing was slice. Now, slice is very useful. Now, I'm going to keep this sketch, but before I work on it, I'm going to show you guys something else. Now, I'm going to finish this. So I have a half ring. I'm going to make a full ring with my mirror command. Okay. I want, not this time, I don't want a feature. I want the whole body to be mirrored. Okay. Select my object. And for my mirror plane, I'm actually going to use its own surface, which you can do perfectly fine. And instead of new body, I'm going to say join. Okay. So now I have a full ring. Okay. But I still want to work on this projected sketch. So what I'll do is I'll edit that sketch, okay? But now the mirror is gone. So let's see if we can change places. Let's see if I can pull the mirror back, okay? Now, and this is the first time you guys are seeing it, which is completely fine. You will see this in Fusion a lot. It's giving me these yellow-orange lines, okay? And the history is marked with this. Now, this is telling you that you're losing a reference. This is important because once you lose your reference and if you start making changes, your model will not adapt to those changes. So let's see what's going on. We can click this exclamation mark on the right hand side. Now it's saying, okay, it's saying reference failure. The sketch plane is lost. Cache is used. Now the cache is important in Fusion because it remembers something that you did in the past, but it knows it's not referenced anymore. So it will keep this from its cache unless or until you start moving things around. Okay? So the same problem exists for all the projections. Okay? Let's close that. Let's click that. Now, the reference that it's looking for is the sketch plane. Because we moved the mirror back, Fusion is not able to locate that plane that we sketched on because this is a whole object now. Okay? So let's do something. Let's move our history marker back and let's create a plane right there. So what can we do? Well, what we can do very easily is go into tangent plane and create a plane. But here's the problem. This plane is tangent to the outside. I need a plane that goes through this. Okay? This way, if we do it this way, it's going to take 3 commands. So we can create a plane here, a plane on the other side, and we can create a mid plane. Okay? Let's not do that. Let's see if we have something else that we can use. Okay? Let's see. We have plane at an angle, which is great because we have an axis going through our ring. Let's click that, and let's turn it around to 90 degrees. Great. Now we have a plane, and I can make that plane bigger, just like I can extend my axes. This doesn't mean anything, by the way, guys. Adjusting the size of your planes doesn't mean anything because these planes are just representative. These planes are actually infinite. They're not, I mean, making it smaller doesn't change anything. Okay? It's just for visibility. Now that I have this, I can go back to where my sketch was, and I can right click my sketch and I can say redefine sketch plane. Okay? And I can say, yeah, that one. I want this to be my new sketch plane. And say okay. Now, here's the thing, and you will see this. Fusion looks at surface normals. Okay? The sketch surface normal was different than the plane sketch normal. So let's see if I can do something about this. Let's undo. Select my sketch plane. Okay. Instead of 90 degrees, let's see if I can say, if anything changes when I say 270. Whoop, 270 is not accepted. Let's see, minus 90. Okay, minus 90. Okay, let's try that again. Let's say redefine sketch plane, select that one, select OK. Now it's in the right place. Okay. Sometimes you will face this. All you have to do is turn the sketch plane around, because even though it doesn't look like it, but this sketch plane has a normal. Okay. Which means it has a vector that is pointing towards the positive side and the negative side. And this sketch plane had a positive side and a negative side before we deleted the plane. They have to match. Okay? Now let's go back into our, let's see what happens when we edit sketch. Okay. Now, the relationships of this sketch is lost, but we're not worried about that right now. Okay? We want to see the sketch. However, our sketch and the placement of the plane is in the middle of this ring. And when I look at it, I'm seeing the whole outside of this ring. But I just want to see where I'm sketching. At that time and in those situations, you can select slice. And as soon as you select slice, the model will be sliced by your sketch plane, and you will see where you're sketching. Okay? As you can see, the model has been sliced by my sketch plane. The other side of the model is not lost. It's still there. When you unclick slice, you will see it. So this is just a presentation for you to be able to sketch on that plane without any intrusions. Okay? So that's how you make a projection. That's how you make a slice. Okay. So there you go. Now, I want you guys to, let's finish the sketch, practice on sketching constraints, constructs, extrusions, and revolve. Okay? If you do some mirror and projections while doing that, that will be great, because from this point on, we talked about anything, everything that is related to the configuration and adjustment of sketches and the configuration and adjustment of our sketch planes. So the rest from this point on will be based on features. Okay? So a little bit practice will be good. And after our next lesson, you will have your first assignment. Okay? I'll see you next week.